Awesome. Okay, so I'm going to go over some things about data cleaning, wrangling, and scoring in R, which is kind of one of my favorite topics. So first, I just kind of want to talk about what is tidy data. So a lot of you probably already know this, but it's kind of a way to organize your data so that it's consistent across all your different data sets. So where each variable is column, each observation is a row, and each cell is a value. And I like this quote, that's tidy data sets are all alike, but every messy data set is messy in its own way, which is so true. And you'll see kind of when we go through more of the scoring that when you get used to working with this like tidy method, it's really, really easy to apply the same scripts, the same analyses, the same plots across a bunch of different data sets that you collect when you kind of set it up in this tidy way. So what is Tidyverse? So there's several ways to kind of wrangle your data into this tidy format, but Tidyverse has some really great and easy functions. So that's kind of what I'll focus on in this first part. And then I will do a tutorial where I'm kind of showing you guys what my process is for having a script that I set up to clean and score questionnaire data. So Tidyverse is a coherent system of packages for data manipulation, exploration, and visualization. And it includes things you've probably heard of and love, like ggplot and dplyr and tidyr and others. But these are kind of the main ones, and we'll have a whole section for ggplot later, so I'll mostly focus on the second two. So I just kind of want to first go over some of my favorite functions from a few of these packages. So filter is a way to only include observations that meet a specific criteria. So for example, if I want a data set consisting only of females or only of individuals with depression above an average score, you can use filter to really easily create a new data subset with just the criteria that you are interested in. So this is particularly useful when your data has many waves or arms. So if you're collecting longitudinal data and you just want to analyze a subset that is the first wave or the first data collection point, it can be really easy to kind of filter your data based on wave and filter out everything except for wave one if that's what you're interested in. So the syntax for that is pretty simple. You would put your, you would name a new object data female, then you would use the filter function, call the data frame that you've already loaded in, and then your criteria, so sex equals female. And you can do this with a bunch of different things. You can use functions, you can use calculations. So here we can see that if I wanted to filter out, say I wanted to ask a question where I'm only looking at people who had a depression score above average, I could create a data frame called data above average, and then filter my already imported data set on this variable, where this variable, depression 1, is greater than the average of this variable, if that makes sense. So it's just a really easy way to kind of filter your data easily. And I'll show you what that looks like here. So if I just run this function, which just shows me the first few observations of my new data frame called data female, then I'm selecting a few columns from that to display here, I can see that all of the observations here are females. So I have filtered successfully this to be a data frame with just females. And then similarly, I can see here, if I run the function that calculates the mean of the depression 1 score in my data frame, I can see that's 55. And so in that subset, that filtered subset that I ran earlier, I wanted to filter out anyone who had a depression score below the average. And so here I've just shown the first 6 participants, and I've selected a few columns so that you can see them here. And you can see that all the participants in this filtered data set have a depression score above the average. Yeah. Okay, so another similar one, but really useful, is called select. And you can use select to only include variables of interest. So for example, if I wanted to create a subset 1 where I only had age, sex, anxiety, and a measure of early life stress, then I could use this selection tool to feed in my data frame and then select each variable by name, by column name that I want. And this is really useful when you have a huge data set where you have tons of variables and you just want to quickly kind of narrow it down to the things that you're interested in, that you need for your analyses. And it just really makes it easier to work with. Another really cool function that I use all the time is these things called selection helpers. So there's a few different ones, some being contained, starts with, ends with. So say I wanted to filter say I wanted to select only the variables in a data set that were for the depression questionnaire. Let's say I had a depression questionnaire. So if I name all of my variables, which is something I'll talk about when we do the tutorial, if I name all my variables with a prefix that corresponds to the questionnaire that I'm interested in, so like depression 1, depression 2, depression 3, I can really easily select only those depression variables by using this selection helper called contains, and then the string depression. So this is extremely useful. You'll see this in the tutorial. And there's several other ones, so like starts with, ends with, matches. And this is really useful when you're trying to score individual measures. So when you have 50 questions from a single questionnaire that you want to score, and you want to kind of subset those so that you can do that before you add it into your kind of clean data set. So here you can see that first subset that I did, I selected these specific variables, and that's the only variables that are included in this subset now. And then here you can see that I selected only those variables with depression in it, and also participant. So I kind of forgot to say that. I also added the participant here so that I could have the participant ID as the first variable, and then the other variables of interest, so that I keep that together with their ID in case I need to combine them later. Okay, and then mutate is a way to add new variables while preserving existing ones. So let's say I wanted to create a variable called anxiety norm from my anxiety variable that I have in this data set. You can basically just feed in the data set. You can name the new variable that you want, and then tell it what that variable should consist of based on some variables that you already have in your data set. So like anxiety divided by the mean of anxiety will give me this new variable called anxiety norm. And if I just print out the first 6 participants in this new data set, you can see that there is, and select the variables I'm interested in, you can see that this is the anxiety score. And then this is the new variable that we've created called anxiety norm that was based on the data that we fed into that function. So this can be really useful, and you can use all kinds of different things here. Okay, now I just kind of want to talk about a kind of bonus thing. So what we've talked about so far is kind of normal syntax. And so the way that we've been putting this data in here and these functions in here, and it can be kind of difficult to read when things get really complicated, because it's like a focus on the nouns, the data set itself, and you kind of have to read it from the inside out because you're nesting functions together. So basically what this is saying is, in an object called data new, mutate a variable using data, using our data frame. But there's this really cool thing called a pipe operator, which is technically from a different package, but when you load Tidyverse, it includes this function in the rest of the packages it installs. And it looks like this thing, which is really weird at first. You're like, what is this %% thing? But it makes it really easy for you to kind of read your code and make sense of it. So it focuses on verbs, so it's more like the way that we kind of think and speak. So you could think of this as, in an object called data new, take my data and then mutate it like this. So instead of having to put my data here and having to know kind of where I need to put my data into this function, you can say, take my data, do this, do this, do this, and you can nest those together too. So I could put another pipe operator here, and I could do as many things as I want with this operator. And you can use it with all different kinds of functions. So that can be really useful, and useful to make your code readable for yourself and others. Okay, then there's the Tidier package, which is a little bit fancier. There's a ton of different functions that this package can do, and I'll just point out a few of them. There is pivot. So a lot of the time you will need to convert your data from long to wide format. So you can see the two different kinds here. This would be the long versus the wide format. And it really depends on kind of what kind of analysis you're doing, but a lot of times R prefers this long format, especially if you're trying to make plots and things. Some other packages I know, like SPSS and some other things, more so prefer the wide format. And so there will be a lot of times where you have to convert it. And there are these two amazing functions to automate that. So if you've ever spent a really long time trying to convert your data from long to wide, you'll know how tedious that can be. And so these functions can be a little bit difficult at first to kind of try to figure out what you need to put into the function and what you need your data to do. But here you can see that they basically took these columns, they put the names to year. So this goes to here, and then values to cases. So it just really easily converts these two. And these two images are from this cheat sheets that R has on, but there's a bunch of different cheat sheets if you go to tidyverse.org, and they're super helpful because they give these kind of visual examples. Similarly, there's a thing called separate, which can separate this variable into two different variables. And you can do that with variables, or you can do that with rows. So this is kind of making this variable sort of into long format where you have multiple instances, but you have, you know, the year and then the rate. So it can make several rows, separates a column to make several rows. And then unite, which kind of does the opposite. So it collapses across several columns to make a single column. And I think the easiest way to kind of try to get used to these is by looking at these photos and these examples and seeing exactly what you need to feed into the function to make it work. Yeah, so you can find all of these cheat sheets and more for each package at tidyverse.org. And this is just an example, and they're really great. They have all of these different functions. They have examples, they have images. Yeah, so really helpful. Okay, so now I will show you kind of a data cleaning scoring tutorial type thing. Okay, so this is kind of just how I do things, but I found it to be really helpful. I like to use these R Markdown documents, which you may have heard of before. And basically what that allows you to do is to knit together all of the information that you have in your R script into something that looks like this. So let me just show you. This is kind of the final product that I'll be talking about today. So it's really nice because it kind of creates this table of contents for you, and it has all of your code chunks. It has regular text that you can write and describe your different variables. And you can even output tables and plots. And so this is kind of what I would do if I was cleaning a data set for the first time and I wanted to have an overview of my means and standard deviation and the range of the data. And I wanted to have a look at the distributions. And I wanted to really describe the way that I score each questionnaire. So I'll come back to this, but now I'll show you kind of how to set that up. Okay, so these little things are called code chunks, and this is what will actually run the code when you're running R. And then here you have markdown syntax, which is like where you add your titles and your headings and your text. Okay, so you'll probably need to install, and I will also upload all of these are on my GitHub account, so I will send that in the chat when we're done. And you can kind of play around with this and run it yourself and look at the data and everything. Okay, so the first time you'll need to install all of these packages, but you only really need to do that once. Then you'll need to load each package every time you open R. So I'm just going to do that. And with these code chunks, you can run the whole chunk by just pressing this button here. Okay, so then I'm going to import my data. So this function here will import your data from your working directory. And if you're using an R Markdown, this is the root folder that the R Markdown file lives in. So if I show you, this is my script here. And so it's going to pull anything from this folder. So if I want to pull this data raw file here, I just need to specify data raw. I don't need to do, you've probably seen before where you can specify a specific directory, kind of like doing like this, like Emily, users, home, whatever, which can get a little complicated if you're sharing your code with other people. So it can be really helpful to create these folders and to have them be all relative to each other so other people can download the whole folder that you've created and run your code exactly the same as you have it on your computer. Okay, so I'm going to read that in. And I'm just going to kind of save another data so that I can have this as my untouched raw data. And then I'm going to create a new data frame that just has the participant IDs. And you'll see why I do that in a second. So now I have my 3 data frames here. I have my raw data that I'm not going to touch. I have my data that I'm going to kind of manipulate and do things with. And then I have my scored data, which is just the participant ID for now. So this is the very first variable that I'm adding. And then I like to define a couple different functions that I'll use for the scoring. So the first one is just checking if a subset, if a whole row is more than 70% complete. And then I use that function within this mean imputation function to impute the means for things for subsets that are more than 70% complete. So there's a lot of mean imputation packages and functions, and it's really up to you and your best practices for whatever you're doing to decide if and how to do mean imputation, but this is just a really simple mean imputation. So I'll just run that so that it saves these as functions that I can use later. And then I kind of like to group things into different, if it's a lot of questionnaires, I'll try to group things in by topic. So, and this is actually a real data set that we collected last year online, and I got permission to share just a subset of that with you guys. I find it so much easier to kind of talk about a real data set and score a real data set instead of just kind of abstractly talking about it. So yeah, feel free to play around with this as well. So the first thing that I will do is I will use this contains function that we talked about earlier, and I will subset, because I'm scoring the somatic symptoms questionnaire, here I'll subset only those questions from the raw data that contain somatic symptoms. So if I run that, you'll see here now that I have 15 variables. And so this is just the questions from this questionnaire that are related to the somatic symptoms questionnaire. And then I'm going to run the way that you score this questionnaire, and this is kind of things that you have to know from your research. How each questionnaire is scored is really simple. It's just a sum across the whole subset. So one good thing about subsetting things and then adding them back in is that it can be really easy to do things like summing. So I'm just going to use that function row sums, and I'm going to round, and I'm going to create a somatic symptom score for each person. So now here I have a vector of the total for each participant. And then what I'm going to do is, remember I created this data scored data set here that has just the participant ID. I'm going to column bind that with my new variable that I just scored, which is the SS score. So if I run that, now you can see in my data scored, I have 2 variables, and I have each participant ID and the sum score for the SS questionnaire. And then I think it can be really helpful to kind of just have a few descriptives in here. And this is functions like some code that I wrote a long time ago, and I use for almost everything, because I can just substitute basically the variable name, and it's super easy to substitute different data sets. So I'm just kind of using a function called describe to gather some information about this variable. and then I'm selecting some things that I want to output and rounding it, and then using this function called cable, which makes these really nice tables, and then plotting it. So I'll show you what that looks like. It looks better when you actually knit it together. So I have for each questionnaire, I have kind of a scoring section and then a descriptive section. So here I can see for this variable, I have this many participants, this is my mean, my ST, my median, min, max, and you can choose pretty much anything that you want to display here, and then a histogram just to kind of look at the distribution of this variable. Cool, so same thing here. And here I'll just talk about a couple things that if you have a slightly more complicated scoring. So here I needed to, this is a childhood trauma questionnaire, an early life stress questionnaire. So I first subset again this. I needed to recode these variables because they were entered, and this is a common thing that you find if you enter things on Qualtrics or RedCap or something, and they're not quite the numbers that you actually need for the scale. You can recode them, so 0 becomes a 1, 1 becomes a 2. Then a lot of times there will be a reverse scoring component to a questionnaire, so you'll need to reverse score specific items. And so this will be things that you actually look for in the questionnaire itself, like the PDF version or whatever. And then this is a subset of this questionnaire that was not actually a part of the scoring. And so I'm going to recode it the way that it's supposed to be, but then I'm going to remove that. And you'll see here, you can similarly, like you can use select to select which variables you want. You can also use this minus sign in front of variables to select things that you don't, to remove things that you don't want. And so this is really helpful as well, just because if you're looking at this data set in like 2 years, or your collaborators are looking at it and they're like, I don't understand why these 3 items are left out, or what these 3 items are. It's just really easy to see what they are and why they were left out. And you can even add, you can be really detailed with the amount of information you put here. So if you wanted to even have a description of each questionnaire, each variable, that can be really helpful. And then again, this was a sum, and then I did that again. And then some questionnaires are way easier than others. So like this one, again, is just a sum. And then it also is very helpful because to have these kinds of scripts like this, because there will often be some small errors in either data collection or something was changed in the middle of the study. So we had one item for our BDI questionnaire that was scored, that was coded incorrectly. So coded incorrectly on the back end when data collection was happening. So we're able to fix that here, and we're also able to note that so that when people look at the raw data in the future, they don't just add up all the things, and they can know that this needs to be changed. There was also some more complicated variables where there was a sleeping and an appetite question where it had multiple parts, one to indicate excess, like more than usual, and one to indicate less than usual. And so those got the same score, but they were coded as different things. So both 4 and 5 need to be 3. So you can recode that like that. And then here is where I would use my mean imputation function if I decided to do a mean imputation for this data. So I didn't for the earlier ones, just to show you really how simple it can be if you're just doing a simple thing like a sum. But here, if I want to impute the means for those individuals who had at least 70% complete on the BDI questionnaire, I can just run the subset that I've created through my mean imputation function that I created earlier, and that will impute those for me. And then again, just things that are really specific to this questionnaire. So we did not include a suicide question that was on the BDI, the Beck depression inventory. So we wanted to impute the mean for that variable so that we could compare across different studies that use the BDI, because otherwise we would have been, everyone would have been like 3 points lower, or however many their mean was. Yep, and so we just do that again, bind them together. And then I'll show you one other thing, And feel free when you get this code to kind of like play around with it, look at the different ways you can do things. And another great thing is once you have this code for certain questionnaires you use, you can really just recycle the exact same code to score all of your studies that use the stay, for example, or the BDI. And then one final thing, well, two final things actually. So the only other kind of thing that you might want to do, well, I mean, there's a lot of different things, but the one common type of thing is to score or recode questions that are more nominal, so like categorical variables. So for instance, sex and gender and ethnicity. So here you can see how I have factored these different things. So in this data set, it was 1, 2, and 3. And I find that I like to factor these variables into words so that I know exactly what each label stands for instead of having to remember or write it down somewhere else. And R is really good in that it treats factors as factors anyway. So you can get the same results basically if you have factors as if you have numbers most of the time. So this is how I would kind of re-level each variable as the actual factor itself. And then here we had, this was one that's it's a bit difficult. We had an ethnicity or race ethnicity question, and it was checkboxes. So checkboxes are a little bit different. So there was each different ethnicity and then a checkbox. So I created a new variable for each ethnicity and labeled those. So basically, instead of having, you know, a one column for each ethnicity and a 1 or a 0, there was just one column for ethnicity, and then it said the actual name of the ethnicity below. And then for multiple ethnicities, you could check. Here I added them all together, and if it was greater than 1, so they indicated, because it's a checkbox where you can check multiple things, if they checked more than one thing, then there would be a 1 in the column that says that they checked multiple ethnicities or not. And then again, you can use these cable functions to get really simple summaries of your data. So if I go here, it's demographics, this is the scoring that I just talked about, and then the descriptives, and this is the code, and this is the output. So you can see the different quantitative things for the age, and then you can also just see this counts for these different categorical variables. And then one final thing that I like to do is a few like sanity checks, I call them, to just make sure I scored everything, or hopefully scored everything correctly. And that's kind of just by correlating or looking at scatter plots of variables that I think should be correlated and seeing how that looks. So in this data set, we have a measure, we have 2 measures of early life stress, the ACE and the CTQ. And so you'll see more about how to create these plots later, but you can just add a plot just to kind of see how those 2 things correlate, and they seem like they correlate quite well. And you can run a correlation test, and you can see the output, the 0.74 correlation and the p-value for that. And then also something a little bit less similar, like the STAY, which is an anxiety questionnaire, and the BDI, which is a depression questionnaire, which typically are quite correlated. And so I can just kind of make sure that there's nothing too crazy going on with my data if I do something like this. And then finally, so I have compiled all of these variables and all of these scored variables into a data frame called data scored in my markdown file. And so the very last thing I'm going to do is just write this CSV, and I'm going to call it data scored. And when you run the whole, if you were to click run all here, it will just write out that new data set here. So now in here, I can see that I have my raw data, which I imported at the beginning, and I have my scored data, which is going to have just the variables that we just scored. So SS, CTQ, ACE, all of these things, and they're all really nicely laid out. And here you can see what I mean by the categorical variables of having the label. And I think that's about it for my section.